So, shall we get started, please? Okay. So, now we have understood how the external virtual work is related to internal virtual work. Okay? Now we will use this statement to work out our deflections. Now how to make use of this? Let us try it on this. Imagine, let's make it other way around. Imagine my virtual system. Imagine I'm given a beam which is subject to UD, okay, and I am asked to find out deflection at a particular point. Okay, so let that be this point. Okay, I am asked to find out deflection at this point. Now what I can do is, I can apply a load at this point, say that, let that be P. Okay? If I apply load P at this point, what will happen? What will be my external virtual work? P into delta. So external let that be delta or okay, so P times delta, that is my external virtual work. That is equal to internal virtual work. So how can I find out my internal virtual work? Integral the moment diagram equation times K of x. How can I find out my K of x? What did we say? K of x is equal to m over EI, isn't it? 1 by rho is equal to m over EI. Agreed?
Yes, sir.
But this is m. This is not m bar. So if I write, would I be wrong in saying that m of x by EI dx, can I? This is virtual, this is real. This real is coming from the value of kappa, which is m over EI. Okay? But I am interested in finding out delta. How can I find out? I'll divide it by P, that's one way, or what is the most easiest thing to do? P, yes, you take P1. So that's why, if P is 1, that's why we call it a unit load method, because P is equal to 1 and delta is this. Do you understand my point? So this is our unit load method. When you apply it, you can apply this formula on beams and frames. Okay, but notice that you have to work out your moment equations. So there will be two moment equations. Okay? One would be for the virtual and one would be for the actual. You multiply them, okay? You integrate them and you get your deflection. Yes?
Can you repeat how K is equal to M over EI?
Sorry? How?
K is equal to M over EI.
K 1 by rho. This is from the engineer's beam theory, from the Euler-Bernoulli equation. What is the Euler-Bernoulli equation? What is your Euler-Bernoulli equation? Okay, and but how is this derived? This thing we discussed in detail. We said that if you have a beam, okay, and you take one fiber over here, okay, you take a fiber and you take a moment of that fiber about the neutral axis, so that will be equal to M is equal to summation of moment is equal to how much? Stress into A into Y, and assuming that this is at a distance Y, this one is at a distance Y from it, yes? Now what is stress? Stress was? Huh? We did it twice, thrice. What is our stress? E times strain. And what was strain? Strain was equal to Y by rho, wasn't it? We derived that Y by rho. So it's that Y by rho, when you put it and integrate it, you get d2y, you get this 1 by rho is equal to M over EI. Okay, please check your previous lecture, and we have derived it twice. Okay, so that's how this is derived. I'm not going to go deeper into it because then this will take the full class. Okay, but that's how we derived it. Y by rho, and then from there it's just the fiber, you take the moment about the neutral axis. Okay, so that is what we have. Now, what if we want to apply the virtual work equation on a truss system? On a truss system, how can we apply? Can anyone tell me? Like, for example, let us do it over here. Should I, let me rub it off. Okay?
Yes.
Should I rub it off?
Yes.
For beams and frames, we can apply this equation very straightforwardly. But for truss, it's even more simple. Imagine I have a truss which which looks like this. This is a real system. Okay, and I'm asked to find out deflection delta. Imagine, I'm asked to find out delta, actual delta. Truss is subjected to some loading like this, arbitrary loading. What will I do? I can use the same structure. Apply a virtual load in what direction? I'm asked to find find out deflection delta in this direction. So with in the x direction. Yeah, in the x direction I should apply. What should be the magnitude of this load? 1. So 1 unit load I should apply. So external work is 1 times delta is equal to internal work. What is the internal work? No, M bar we don't have in trusses. This is, so in trusses what do we have? M bars we have in beams and frames. So in trusses what do we have? Extension. So tension or compression, axial force. So what should, so instead of this we should have axial, but that should be virtual, shouldn't it? So imagine whatever internal load I get, that I call T bar. These are all T bars, okay? So T bar is the internal force. T bar is the internal force. Under this unit load, this one, all these members would have some forces, isn't it? T bar is the internal force in this. Agreed? Similar to, we had moment which was internal to the beam. Agreed? And multiply by what? What should be the analogous thing to curvature? Sorry? Extension. Yes. Displacement or extension. Yes. So extension E, but that E should be virtual or real? Real. So the extension. So in other words, what is this E equal to? What is E equal to? Extension. This extension is equal to? Which is equal to? PL over AE, isn't it? Yes, this is PL over AE. So this P is actual. Do you agree with me? So please notice, I repeat, we have got real system, we have got virtual system. We are asked to find out deflection, say, in any direction. Okay? We will apply unit load in that direction. That unit load, it can be any direction. Not necessarily it's horizontal or vertical. Okay? So you have, so external work is 1 times delta. Yes? And the internal work is the axial forces internal forces in the virtual system. So all these are, so I should put a summation also. So I should put, because T bar is many, isn't it? T bar is not one. There are many T bars. T bar times E, okay, and integral means summation. Yeah. So this is the internal. Every member. So what do we have to do? And E is equal to PL over AE. Now what do we have to do? We have to first of all find out the internal forces. You have to analyze this truss. Yes? And you have to analyze this truss also. Okay? Now after that, once T bar and P's will be known. Yes? You should find out the lengths. Okay? AE might be given to you. Okay? And so you multiply all of them. You take, so we have to draw it in a tabulated form. So imagine I have this as A, B, C. Okay? A, B and C. So I have to draw it in a tabulated form. So let us say I call it member. Okay, first column will have members. So members would have AB, BC and BC. Okay. Then I will have T bar, T T bar would be of some magnitude. Okay, imagine this is in kilonewton. So say A, B and C, whatever. From here we will get some value of A, B, B, C. This is T bar. Agreed? Agreed? Okay, this is the structure analysis we will get. Then we will get the P's. So some value, you will structurally analyze this one. Yes? Agree? Then you will have lengths. You will have areas in meter square or whatever. Please you'll be consistent in your units. You will have E. E most probably would be of the same material, so E will be constant. Okay. So once this is found, then what will you do? You have to multiply T bar with E. So you will find out your E. What is E? Is equal to PL over AE. So this P will be divided by AE. L times AE. Okay? So you will find out your E. Then you will multiply that E with T bar, all of them. Okay, so let me T bar E. So you will get T bar E. Agreed? Are you with me?
Yes, sir.
And once you find that, then you will find out the summation. Okay? Whatever you get, that is your delta. Is it? That's what you have to do. So regardless how big or small your truss is, it will be a determinate truss. That is obvious. So you can use this method and find out your structure analysis. Okay. So shall we do one problem on this?
Yes, sir.
Okay. So I'll just rub off the whole board. Why are we taking?
Only one load in one direction.
You might be asked in the question to find out a vertical deflection also. So for that you have to do another one which will have a triangle, another virtual system, and load might be applied in this direction. Okay? And you can do the same exercise for this one and find the vertical deflection. So you will know the horizontal and the vertical deflection. Okay, but this is just an example of this. Sorry, no. Okay, no. I can't restart. Okay, guys, guide please. So I'm rubbing it off, okay, all of it, because it's a very straightforward problem. And Monday I'll then restart from everything. You don't have actually time. I'm rubbing it off. Okay. So we have to find out vertical displacement of C. Okay, vertical is, so we have to apply the load in the y direction. Okay. What is this?
दोनों डायरेक्शन तो ऊपर नहीं
What is this?